Okay, I think we are recording. I hope we're recording. So, second lesson. All right, welcome back. Hope you guys are doing well. This is continuing the previous lesson. Okay, it's nothing different, like a separate thing. So when you're doing your notes in your notebook, just continue writing stuff down, examples and so forth. Please have the reference sheet handy. It does have some things that we're going to use. Okay, and it'll be easier for you to take notes. So we're going to talk about the real number system today. We have identified, at least you have in the past in Algebra 1, properties of real numbers. Okay, now we're going to classify real numbers and use the properties of them to evaluate some expressions. Okay, and that's all we're going to be doing today. So here's some vocabulary. All the different types of real numbers. Complex, that whole realm of complex numbers, the imaginaries, we'll talk about those in a separate lesson. Okay, so that's kind of like a stay tuned for more type of thing. Okay, so here is a nice chart on the reference sheet, by the way, of our real number system. Okay, so notice it's composed of natural, whole, integer, irrational, and rational numbers. This should be a review from Algebra 1. And we have our symbols: N for natural, W for whole, Z for integer, I for irrational, Q for rational. Now, why Z for integer and why Q for rational? Kind of an interesting story with the integer one, to be honest with you. But rational, the reason why it's labeled Q is, well, quotient. Okay, you get rational numbers from fractions. Okay, so for instance, 2/3 is 0.66 repeated. Okay, so anything that's repeated like that, or just have a terminating decimal like this, okay, those are rational numbers, fractional numbers. Okay, irrational are the ones that go on forever and don't end, that have no pattern. Okay, that's important. It doesn't have a repeated pattern. That's the difference between these two. So we know pi is one of those, 3.14. Square root of 3 is another one. Okay, so there's some examples for that group of numbers. We have integers, okay, which are positive and negative numbers. There's no decimals in that realm. Okay, positive, negatives. Whole numbers, it's a subgroup within integers, but they only have the positive numbers in there, and zeros included. Okay, so whole numbers are all positive numbers with 0. And then for natural numbers, that's what you started with in grade school, elementary school, where you counted 1, 2, 3, 4, 5. Okay, no negatives in that group, and 0 is not included. Think about it. When you started counting in first grade, did you go, all right, 0, 1, 2? No, you didn't do that. Okay. Now, if you look at the chart here, you can see how all the natural numbers, all of these guys, are seen in the whole numbers, right? Okay, but there are some whole numbers that are not part of the natural numbers. So that's why this nice little Venn diagram picture is showing you that there's subsets. Okay, what's out here is 0. So the difference between these two is just 0. Okay, notice all the integers have these whole number and natural numbers. It also is contained in rational numbers, Q. Okay, so every integer can be written as a quotient, right? For instance, 5, or we'll use a different number right now. How about 10? 10 can be written as 10 over 1. Okay, that is a rational number, and it is an integer, because when I do the division, I still get 10, right? Okay, so that's why all the integers are part of the rational number realm. Okay, over here are irrationals. They're separate. They don't have anything in common with these guys. Okay, and the whole picture here is under the real number system. Okay, we could, you know what? We're going to include it. So here's real numbers. So if you want to put this on your reference sheet, you can. Here's real numbers. There's a separate area over here for complex. Okay, complex numbers, which are imaginary. Okay, a little bit different, but like I said, we'll deal with this realm later on. So technically, we should have a whole nother grid just for complex numbers. Okay? Now, why does integers have the symbol z? Why don't you look that up? Okay? It's a cool thing, but look it up. Why does integer have the symbol z? Okay, I give you a hint. It comes from a German word. Okay, so I'll leave it at that and just explore it a little bit. Okay? If you have questions, let me know. So we're going to classify these sets of numbers. I encourage you to pause the video so you can try this out yourself. Okay? And we want to name all of them. All the sets. So here we go. Square root of 6. If you plug this in your calculator, it's going to be a decimal that has no pattern. It just kind of goes on forever. So it would be like 2, and then 4, 4, 9, 4, and it just keeps going. Okay? So we know from our chart, and just from our basic knowledge of it, that this would be an irrational number. Okay? It's also still classified as a real number. All right? Now notice something. I did put like an extra line here. A lot of times you're going to see that notation. They really capitalize that R. They try to make it a little bit more significant. So a lot of times you might see that. Okay? Let's look at 5. Okay? What does 5 belong to? Well, we could classify that as a real number. It better be a real number. Okay? It's also a natural number, right? Natural numbers are also called counting numbers in a way. It could be a whole number. It could be an integer. One final thing, too. It can also be a rational number, okay? So it's all of these things. 1, 2, 3, 4, 5. There's 5 groups for that one. And the last one, negative 2/3, okay? Well, it's a real number, right? There's nothing imaginary about it, nothing complex. Is this a natural number? No, it's not a counting number, right? If you guys remember, what's negative 2/3? Negative 0.66 repeated. Okay, so it's definitely not going to be an integer. It's not going to be a whole number. So our only option, and it's not irrational because it has a pattern, so it just has to be a rational number. Okay? So there we go. That's listing all of the number groups that these particular examples belong to. Okay? And you're going to have to do that on your homework assignment as well. Next one. Okay? What does negative 2 52/100ths belong to? What set? And pause the video. Well, is it a real number? It is, right? It's definitely a real number. Can we classify that as natural, whole, anything like that? No. So option C is not going to work. Because it has a pattern, because that bar represents that that's a pattern, I think we can safely say that D is going to be the correct answer. It's a rational and real number. It's not irrational, and it's definitely not none of the above because it is one of those. Okay? So there's another example for you. Next, okay, properties of real numbers. Now, you've seen commutative and associative before, but identity, inverse, and closure, you've seen distributive. But these three is something a little bit different, maybe new for you guys, okay? And notice we classified these real number properties in addition and multiplication, okay? These come up a lot if you go to college and take like an abstract algebra course or even a real analysis course, and you'll talk about these properties a lot, okay? So commutative, that just means when I'm adding, it doesn't matter what order I add two numbers, right? 1 plus 2 is the same thing as 2 plus 1. Nothing changes. If I multiply two numbers in any order, I get the same answer. We know that. Associative is grouping, right? If I'm adding, it it doesn't matter what two numbers I add first. I'm still going to get the same answer, right? So see how the grouping changes from the first two to the last two, okay? Still going to get the same answer. And if you're not convinced yourself, plug numbers in. Okay? You'll see that it does work. Now, this one, same thing as multiplication. If all I'm doing is multiplying three numbers together, it doesn't matter what's first or second. Okay, so that's the associative property, the changing of groups when you do the operation. Identity, inverse, and closure. Let's talk about these three because they're definitely newer, I would say, for you guys. Okay? Identity means whenever I add something to a number, I get the number back. Okay? Now think about it. What number can I add to 7 and I get 7 back? What number is it going to be? It's going to be 0. This is the identity element. Okay? So for instance, if I had negative 1,000 plus 0, guess what I get? Negative 1,000. That's what the identity element is. And that's actually pretty crucial when we're talking about group theory, groups of numbers, like what is the identity element? And that's more for a college class, but definitely important, even in an algebra class, at a high school level. Okay? The identity element for multiplication, what number can I multiply by and still get the same number? So for instance, if I had 7/8, I multiply that by what number? I get 7/8. What is that number? And you can see from the reference, it's 1. This is the identity element for multiplication. Okay? That's what they do. They give you the number back. Whether you add or multiply, you get the number back. All right? Now, the inverse. Okay? So we're going to switch this up a little bit. And I'm going to erase these and just rewrite it. So if you haven't wrote this, if you want to write this down, you can. The inverse is, what do I add or multiply to the number, and I get back the identity. All right? So let's talk about that. So let me erase this. Okay. So there's that. Here's 0. Here's 0. Okay. So here, once again, this column represents my identity elements. Just had enough space there. Okay, so what number can I add to 7 to get the identity element back? Well, negative 7, right? We call this the inverse element. Okay, what do I add to get to the identity again? Negative 7. Negative 1,000, what would I add to it? 1,000. Here's my inverse element. Now, that's not too bad with addition. You just take the opposite sign. What about multiplication? How do I get the identity element of 1? The reciprocal. And if you can take a look at the little property over there, it shows you that. So if I flip this, make it 8 over 7, you get 56 over 56 when you multiply straight across, which gives you 1. Okay? If I did 16, what do I multiply 16 by to get 1? Let's change it up. What happens when I just have a normal number, not a fraction? Well, when you multiply it by 1 over 16, multiply, you get 16 divided by 16, which gives you 1. Okay? So these guys up here are the inverse elements for multiplication. All right? So that's what this is telling you here. Identity, I don't want to change the number. Inverse, I want to make it the identity. Okay? Last step, closure. Okay, this is pretty important. Look at what it's stating. It says a plus b is a real number. Okay, so pretty much when I add two numbers together, do I get a number afterwards? Yes. Okay, that's what closure means. And you need that to be part of a group of numbers. Okay, once again, more advanced topics for college. But if you're adding two numbers like 5 and 7, 5 plus 7, does that give me a real number, 12? Yes, that's what closure means. I don't get, 5 plus 7 equals 6i. Well, that's not closure. How am I getting two real numbers and then I get an imaginary? That doesn't work out too well. Okay, it's a little bit different. So just kind of keeping track of that, what closure means is pretty important. Same thing with multiplication. 2 times 3, does that give me a real number? 6. Yes, it does. I don't get 2 times 3 equals 17i, which is an imaginary number. That doesn't make sense. There's no closure in that, okay? So closure is pretty important. If we mess that up, well, a lot of the mathematics that we've done over the years doesn't really work no more, okay? I think we got it covered. When we add 2 numbers, we'll get a real number. All right, distributive, that's just when we take an element outside the parentheses and we multiply to every element that's inside of it, okay? So, apologize that that's a little bit long, but these 3 are pretty important, and it's something that you might have talked about before, but now we're really going to dive into it and practice with it, okay? Let's do some examples. So name the property being illustrated. So as you can see, they have -8, they added 8 to it, plus 15, and we got 0 plus 15. What did they do? Well, to me, it looks like they did the inverse, right? The inverse gives you the identity element. For addition, it's 0, okay? So this, I'll write it down over here so you have it. So for this one, it's the additive, or the addition, inverse property. Okay, that's what we did. That's what's being illustrated here. Okay, they took a number, added the opposite of it, and got 0. So that was the inverse. Next, what property is being illustrated by 3 plus 0 equals 3? I'm pausing so you can think. This one would be not distributive. Is it the inverse? No, because I'm not adding the opposite. Is it the identity property, or is it the inverse property of multiplication? Well, there's no multiplication. It has to be C, okay? They added the identity, so they didn't change the number. Keep that in mind. Identity means you keep your identity. Okay, I'm keeping 3. I'm not changing 3 at all. I'm not changing its identity. Hopefully that makes sense, okay? That puts things in kind of perspective. Okay, next example. Find the additive inverse and multiplicative inverse for -7. Sorry, I'm a little tongue-tied. It's been a long day. It's Friday. I'm just so happy. I don't know when you're watching this video. It's probably not Friday, but I'm happy with that. So here's -7, okay? So what's the addition inverse? And then what's the multiplication inverse, okay? Now, if you have to use the reference sheet, please do. Okay, don't be afraid to. So what's the inverse if I'm adding -7? Because I want to get 0. It's going to be what? A +7, right? Because if I add these 2 together, I get the identity for addition, which is 0. Okay? Now, how do I undo this guy? I don't think that's the right word to say, but what would be the inverse for this when I'm multiplying? Because remember, the idea is I want to get a 1. Well, that's going to be 1/7. But not just 1/7, has to be a negative. Because remember, I want a +1. So -7 times -1/7 gives me 1. Perfect, okay? So these are the inverses, addition and multiplication for -7, okay? Because we want to get the identity element, 0 and 1. It's a lot at first. If you're not used to using this terminology and you're not used to seeing this, so don't be frustrated. It'll be fine. Honestly, it'll be okay. But just look over your notes and just really think about what's being done here. Okay? All right, last one. What's the additive inverse and multiplicative inverse for number 5? It's a hard word to say. Okay, so think about it. correct answer for this guy would be B. B is the correct answer. Okay, right here. So think about it. Here's 5. Okay. What do I add to 5 to get 0? What inverse gives me that? -5. What do I multiply 5 by to get 1? Because I'm multiplying here. It's the reciprocal of 1/5. Okay. All right. Last 2 problems. We're just going to go ahead and simplify an expression. This is using the distributive property. Just once again, it's a good review to know how to simplify things again. You've been doing geometry for a long time. It's time to put your algebra hats back on. See what you can come up with, right? All right. And if you want to solve this ahead of time and then check your answer afterwards, you can. So I'm going to distribute the 4 to both elements inside the parentheses. I get 12a minus 4b. And then this is a positive 2 that I'll distribute to both of these guys. So it'll be plus 2b plus 6a. Okay? Nothing too earth-shattering there. Combine like terms. So if you want to write steps, this is you distributing. So distribute, combine like terms. So let's see, we got a 12a and a 6a. That's 18a. -4 plus 2b would be minus 2b. Okay? And there's my final answer. I really can't go any further. A's are grouped together, B's are grouped together, so this is what I have as a final result. All right? Last one. It's multiple choice, so you can pause the video, solve it yourself. Okay. So let's see which one of these. I'm going to distribute the 2. So it'll be 6x minus 2y. Distribute the 4. I get 8x plus 12y. Now I'm going to go ahead and combine like terms. The x's go together, so I get 14x. The y's go together next. I'll tell you what, let me make a squiggly line. They go together, so that's going to be what, 10y? So which one is it, 14x and 10y? I think that's option A is the correct one for that one. Okay? And remember, the first lesson, the first 2 lessons are going to be a review. All right, I know this is stuff that a lot of you can probably handle. If this is stuff that you're like, oh, wait a minute, I'm messing up, I'm having some errors. That's fine too. You're just practicing. Okay, no reason to admit when you make an error. But other than that, that is it for this lesson. That's the real number system. All right, so stay tuned for an assignment afterwards. Remember, if you have any questions, feel free to ask. But other than that, have a good day, guys.